Hello everybody, February 28th, 2023. Okay, here's what we're looking at. And this got started because I've had a couple of text messages and some emails asking me the question of, Joe, why is it that when I work with a different slide rule than the Cascade Fire Slide Rule to determine my friction loss, all the others give me a different number than the Cascade? Well, that's a good question, and I am going to go over that right now. So you're looking on your screen here, guys. The top one is the April 2010 version of what we used during Engine Academies, S211s and whatnot. This is the one that was revised and what they're using. This is the de facto go-to tool. However, there is I won't say an error, because San Dimas Technology Development Center, or San Dimas National Labs, they did some testing, and they just picked a number pretty much in the middle of the road for their testing. And there is a tech document that came out in 2006 entitled Wildland, Friction Loss in Wildland Hose Lays, and I will have the link to that on the at the tail of this video. But something I want you to look at. Here's how you can tell the difference right off the bat. If you have both the older red label, which is highly accurate, just as much as a green one, and if you've got it, don't throw it out. Also the next one, let me pull up the other slide here. This Akron Brass friction loss and stream calculator. If you see right here, okay, on 100, well, it would actually be on this top section here, where the flow is in gallons per minute. If you set that over to 100, like what they have in this one, and then go to the hose size, so for 1.5 inch, you'll see that that right there is approximately 35 psi. Well, that 35 is the coefficient that is used for the hose. In fact, all of these, when you set the green label, the red label, and even the Akron on 100 up here, and then read the hose size for a single line, these friction loss numbers are the actual coefficient used for that particular size hose. So getting back to this, you can see on the red label, the older Cascade red label, at 100 gallons a minute on 1.5 inches, scrolling up, it was 24. So that means that they use 24 for the coefficient for 1.5 inch hose. Now, on a 1-inch hose, they use 150, but on the green label, they use 250. So you're going to have a lot higher friction loss numbers on the green label than the red label, or even the Akron Brass slide rules. Does that mean that the Akron Brass and the red labels are inaccurate? Absolutely not, because the red label and the Akron Brass and other friction loss calculators, slide rules like this, they use the published numbers. That's International Fire Standards Association. They use those numbers, the 24 and the 150 for the 1.5 inch and the 1 inch respectively, across the country. That is what they use. So if you wanted to ditch the green label, you certainly could, and you would still be just as accurate. Another thing is that you're liable to find that over longer, on very short runs like 1 to 400 feet, you're probably not going to be off that much on your pump discharge gauge on your apparatus. Where you would see the difference is in long hose lays. On the red label for 60 gallons a minute on a 1.5 inch line at 8.6, and we have 1,100 feet, then your friction loss for that 1,100 feet for 60 gallons a minute is going to be 94.6 psi. But on the green label, it's 138. And you can see that if you had the Akron, which I've even got right here as well, you set it up, you're going to get the same numbers as the red label. So you can certainly use them. And I've got a demonstration for you. In talking about the differences, if you have a scenario with 1,200 foot hose lay and you're supplying 60 gallons a minute going up 240 feet, and you have a combination nozzle, 1.5 inch combination nozzle at the end, then the friction loss on the green label slide shows 12.6 psi per 100 feet. even though it looks 12 and a half, and some folks will round to 13, if you do the math, the actual equation, it's 12.6. So if you use 12.6 and multiply that by 12 sections, then you'll see here that you've got 151.2 psi, okay, for the entire hose lay. If you were to set up a second parallel line and Siamese it, then that 151 would drop to 37.8. That's just a for instance there. Nozzle pressure is going to be 100. The head pressure is going to be 104, and then the total single line friction loss would be 355. So the parallel friction loss brings that back down to a total PDP of 241. So 355 and 241. So those are the numbers. So now, Red Label, for the same friction, same elevation and distance, is going to bring the PDP to 307, and then with the Siamese is 229. So, for the single line friction loss PDPs, that's a 48 psi difference. Well, that 48 psi would be an extra 110 feet in elevation, or if you have the, you could get an additional 500 feet of hose distance roughly. By using the Red Label numbers, you could actually extend your hose lay an additional 500 feet, whereas the Green Label is saying you're pretty much out. Even though your pump is still going to be capable of doing the job, assuming it is, that's what you're looking at here. So now there is a way that you can test this. And also, I'll leave this PDF up on the site as well, guys, with a link. So here's how you can conduct a test for yourself to see what more closely matches your apparatus. Because usually the gauges that they put in an apparatus are not all that inaccurate. They're pretty close. So here's a way that you can test for yourself. So you get one of these stackable tip smooth bores like this. I think this one here is a 15/16 over here. Unscrew if you unscrew it, and then on the end here is a 1/2 inch. And to me, the 1/2 inch and 15/16 combo is a really nice combo. And when you set it up on your 1.5 inch for like your type 6s, type 4s, type 3s, you can use it for testing both of them. So if you look at your 1/2 inch size and you get your slide rule, and you look at down here where my finger is on the numbers. In fact, let me go back here. So if you set up your flow right here and place this over the 60, well, I should be down here. Place the 60 over the 1/2 inch and then read what the nozzle pressure is. That is going to tell you where you're going to throttle up to. And so you get a line gauge, attach it to the nozzle, and then attach the line gauge in the nozzle to the hose, and then get your friction loss calculator and look at where it's supposed to be for the friction loss for that. So when you do your test, it should come out to where you're looking right at about 73.5 psi to flow 60 gallons a minute down 100 feet of 1.5 inch hose at 60 gallons a minute through that nozzle. And then if you use the Green Label, it will say that you're going to be at 77.6 psi. And there is another way to determine the friction loss. Now, I'll leave a link to this as well. This is a friction loss nomogram. This is going back a ways. This was largely before the slide rules came out. And what you would do is you would have nozzle or hose, okay? And then this would have flow rate. This line right here would give you your reaction force in pounds as to whether you were on a smooth bore or a combination. Pretty much a smooth bore right there. And so based upon the amount of water flowing through a nozzle, it would tell you once you connected over here to the rated nozzle pressure, and you would draw a line. So you'd print this out and then draw a line, and then that would tell you what you had, and then it would also tell you for the hose size what the friction loss would be. So it was a pretty handy little tool. And then this is the nozzle diameter over here. So you notice that this is a smoothbore setup. It obviously only goes down to as small as a 1/2 inch, and the equivalent internal diameter on a 1.5 inch combination nozzle is 0.4472 inches, and 0.5 is a 1/2 inch. So it doesn't quite go down far enough to be usable for that, but anywhere between 1/2 inch and 3 inch, if you did the internal conversion on a combination nozzle, you could use that nomogram as well. So anyway, I hope that helps, and if there's any questions, again, feel free to contact me. Bye-bye.